Here are the steps. Define the protected surface.
Yes.
Again, we'll define all of these.
Yeah, I might as well now. Protected surface, data, applications, assets, services. These are the things that we've already talked about, but this, in the steps to implement, this is where you define what your surface is. Okay.
Map the transaction flows. Who needs access to what?
Yeah, and we'll go through a couple examples of transaction flows to kind of help make this more concrete.
Architect, which is a terrible verb. Architect a zero trust model.
Maybe because it's a noun too, right?
Right. Build your zero trust model, create the policy, and then monitor and maintain the network, which puts us back to the first thing, because as you monitor, you're going to find surfaces you want to protect that are unprotected.
Well, not to mention you're going to want to add to your infrastructure. You're going to need to be somewhat flexible. Once you have a working architecture, you're going to need to go back and change it whenever anything new needs to be installed. So absolutely, you're going to be iterating over it.
So taking inventory, the first step in defining the protected surface. What's our IoT look like? And this happens to me all the time. Physically, when did we get a smart TV? Why is that thing talking over the internet?
Yeah.
And it is. It's physical devices. You need to know what all of them are.
Yep.
As well as who uses what.
Yeah, so you have assets. You also have applications too, software inventory. And then of course, data categories. What's labeled PII, what's more important than other, credit card information, protected health information, et cetera. And you need to know your categories. So here you have an example of if you were to map transaction flows. We have a couple of examples here as to what you might need to do if you wanted to create a policy. The first step is figure out what all your flows are. So in this case, we have two different flows. This is flow number 1, and in this case, Alice is in finance. She has a payroll app, and she needs access to this database. Okay, so what she's going to do is she's going to go out to the identity provider, might be Active Directory in combination with some other, next-gen firewalls, tightening down the network. So she gets a token, and then this particular flow involves the app actually calls over 3306 SQL directly, as opposed to over HTTPS or something like that. It's actually doing direct SQL to the database. Okay, that's how the application works. This is a flow. All right, so who is it? What is it? How and when? So that it's going back to those tenets. So now flow number 2, Bob in HR has a census app, and he actually needs access to the same database for different reasons. And you'll notice on the far right here, I have the column marked in red. I have a pop-up, so I can't actually see it, but I know it's red because I made it red. It is the social security numbers. When he's running this census, he does not need access to that part of the table. So should we give him access? No, we should not. We should make sure that the app only has access to the 4 columns in blue, not the social security one. Now it's the same database. So Ron, how would, what's a good example of how you would do this? Because I know you've done database.
From a database perspective, you would do it through keeping those two things in different tables and enforce table security.
And then you perform joins on those tables, and that's how the application would see the view of the data, right? So this is another flow. And in this case, the census app is going over 443. It's doing an encrypted HTTPS session. That's how this app works. So this is flow number 2. So, the database is the same in this case, but the view of the data is different, as well as the principal and the application accessing the database.
So when you're architecting it, you have the questions. Who should be accessing a resource? What application is being used to access a resource inside the protected surface? When is the resource being accessed? I've said this before. If Alex finds out that I logged in at 6 in the morning, he can be pretty certain